Hi everyone, and welcome to the second day of Mobile the Days conference. My name is Artem, and I will be the main uh, conference moderator for today. And also, I'm one of the speakers. We'll meet in a few minutes, so it would be quite hard to be a moderator for myself. So I called Alexander from the second day to help me. Alexander, are you here?
Hello, hello. How are you doing?
Hi, I'm fine, thank you. And how are you?
Fine as well. I'm Alexander Denisov, and today I will be a temporary moderator of just one talk. But tomorrow I'm waiting for you who interested in Flutter at the Flutter Day, the day completely dedicated to Flutter. Okay, this is enough about Flutter because today we should talk about Android only. By the way, please write in the comments if you were yesterday on our first day. I wonder, do we have any iOS engineer who listening us right now, or engineers who interested in the both iOS and Android? This talk actually is a bridge between iOS and Android. Artem talks because protocol-oriented programming was actually introduced as a WWDC talk about development practice for Swift. So does it apply to Kotlin? Let's find out. Artem, am I right?
Yeah, you're right. And more than that, I came to this topic during the conversation with moderator of previous day, Danis. So thank you, Danis, for this topic.
Okay, and don't forget to ask your question, because firstly, Artem will definitely answer them.
Yep.
And secondly, the author of the best question will definitely get a prize. Okay, I think let's go.
Yeah, we're ready to start. Okay, guys. Today we're talking about POP, and I want to skip the slides. I already said that my name is Artem Bagritsevich, and I'm lead software engineer at EPAM and head of the Android stream of the Rolling Scope School. By the way, you can join this school. We have open chat in Discord, so just Google and join us. We have a lot of moderators and mentors who are always ready to help with Android stuff. So let's play a game. I want to start from a game. Anyway, I see Swift code. Anytime I see Swift code, it looks for me just like the Kotlin. It's so similar. So I wanted to make the game called Not Sure If Kotlin or Swift. So I will give you just small pieces of code, and you have to determine if it's Kotlin, Swift, or Not Sure If Kotlin is Swift. So let's get started. Okay, just declare an property. So what do you think? Okay, we don't need much time for this. And not sure if Kotlin is Swift. This code compatible with both languages and compilable in both languages. I checked it. You can also check it. Okay, let's go to the next code example. Oops. And now we have bigger code. We have base view, which extends view, and also we have extended view, which extends base view and also overrides some variable. Okay, what do you think? Of course, it's Swift code. And even now, for me, this code looks like some strange Kotlin code. So this rule works anytime. If something looks like a strange Kotlin code, it's Swift for sure. So why it cannot be Kotlin code? First of all, base view is not marked with open keywords, so we cannot extend base view. Also, some variable also have to be marked with open keywords to be able to override it. And of course, these strange getters. But in Swift, it's nice code. So let's move to the next slide. Uh, More code here, declaring class, extending or implementing Kotlin or Swift, declaring the same variable we already saw in not sure if Kotlin or Swift section, using this variable inside the function, and finally we're creating the object and calling the function. So what do you think? It's Kotlin code. But if you thought that it's Swift code or not sure of or Kotlin or Swift, you are almost right, because I can show you the magic. Whoop. And now it's fully Swift compatible code. Uh, did you see the difference? The difference is here in func keyword. That is the only difference, one letter, C. In Kotlin is fun, in Swift is func, but two different languages. And it's so nice that we can write the same code, which will be compatible with two languages. It's quite a big piece of code. And I checked it, it works. And this C letter is the only difference. And that was the last example. I just wanted to show you that Kotlin and Swift is like brothers. It's languages which looks really similar. Okay, but when we started discussion uh, about the difference between Kotlin and Swift with one of my colleagues, Danis, uh, he said that Swift is protocol-oriented programming language, and that's a big difference between Kotlin and Swift. So I started Googling and found that 5 years ago at WWDC conference, Apple announced that Swift is the world's first protocol-oriented programming language. It's quite a strong statement. The world's first language. It's something that I want to learn. And I had a couple of questions. Why Kotlin is not POP? If the Kotlin and Swift look so similar, they have a bunch of similar features, but why Kotlin is not POP language? So I had some feeling that it's tricky marketing from Apple, and looking ahead, I was right. So let's talk today about protocol-oriented programming in Kotlin, and I hope that today you'll learn what is POP and how to use it, what is trade and mixing and where to find them in Kotlin, and why you don't have to believe in everything Apple says. Okay, let's start. And the first thing I did, I just Googled POP. And the first article I found was a Medium post. By the way, you can find every article I mentioned in this speech in the link in the description of this video. First article was on Medium. It was quite popular, and it was called like Introduction to POP. So I tried to understand it. So I opened it, and here what I saw. Let's review this code from this post. We have car class, which has three methods: move, lock, and unlock. And it's quite a simple interface of interaction with car. We can move it from one point to another point, lock and unlock. Easy. Okay, but also we have a ferry, which under the hood has some array of cars, and also has method move, which can run through the cars and call move on each car. But at the same time, ferry can do this: unlock all the cars. It can call unlock on every car, and it's strict violation of encapsulation, of course. So ferry shouldn't depend on the concrete class. Uh, it's the main thing with this, is the main problem with this code. So let's review the solution. Yeah, and the solution is using different protocols. Uh, Author declares movable for moving, lockable for lock and unlock, and also declares loadable just to load and unload cars from this ferry. Uh, so this principle called interface segregation, I heard about it from Solid. We're just segregating quite a mm, big class to small interfaces and using different uh, interfaces for interaction with it. Uh, okay, let's see the solution. Let's see the usage of these interfaces. Uh, and Here we have a car extend which implements movable and lockable, and we have a ferry which stores not the array of cars but array of movables under the hood, and we have the same functions. Now ferry cannot unlock cars anymore, and this is the principle called dependency inversion. We are not dependent on the concrete class car, we're dependent on the movable. It's also quite a main principle from Solid, well known for me. And that was the end of this talk, the end of the article. So uh, where is it? Where is POP? I thought maybe it's some wrong article, or I didn't find something. So I decided to continue investigation. So before moving to the next article, I found we have to learn a bit of theory. So let's understand what is traits. Uh, Traits is something which replaces inheritance. And in Scala programming language, we have even word trait, which is like a replacement for regular interfaces. You can say this example, it even can be used with generics. But also traits can be extended and can extend other classes. At this example, abstract class A has message, and trait C extends A and defines uh, new logic. It's really important that trait C can define default implementation. So trait C defines loud message, which just calls to uppercase. And finally, we have class B, which also extends class A and overrides message. Now it calls I'm Scala. And class D at the bottom, which extends B, but with C. That means that class D will have both message and loud message. Message will print I'm Scala, and loud message will print I'm Scala using uppercase. Uh, yep. Uh, and that's probably all about traits. You just can apply unlimited amount of traits to a class, and that is the way how to avoid inheritance and replace it with traits. And the last thing I want to mention is that traits shouldn't store and handle internal state, but if trait handles and stores internal state, it's called mixin. So don't miss these two, traits and mixins. Okay, in Swift, we have protocols. Protocols in Swift is pretty the same as interfaces in Kotlin, but protocols in Swift doesn't have default implementation, so we should declare extensions. Extensions provide us ability to define default implementation for the protocol. So here in this example, we define protocol named with name field, and also extension for named, which has name, and also extension for named where self is human. That means that this human string will be printed only by human class, which implements protocol named. That's how it's working. But what do we have in Kotlin? In Kotlin, we have the same. We have interfaces, we have a default realization inside interfaces. Also in Java, starting from version 8, we had the same behavior, but also in Kotlin, we have such a powerful feature as extension functions. And finally, in Kotlin, we have implementation by delegation. It's quite rarely used, but we have it. Okay, now we can move to the next article. And the next article is about video game. This article called protocol-oriented programming a tutorial or something like this. Let's review the architecture of the main uh, of the main game. We had motor vehicle and aircraft, and of course we had some childs. Motor vehicle has car and motorcycle, and aircraft has plane and helicopter. But again, we have a problem. What if we're working with a video game in cyberpunk and we can have flying car, or what if we can ride the bird and flying car? We cannot extend flying car from motor vehicle and aircraft at the same time, and bird is not aircraft, so we cannot even extend it from aircraft. So here is a problem, and let's review the solution. And during this solution, I decided to write Kotlin pieces of code. So let's compare. First thing author did is defining interfaces and or protocols in Swift. So protocol flyable, which has airspeed velocity, and protocol bird, which has name and can fly fields. Why bird doesn't have this can fly? Because not all the birds can fly. So what do we have in Kotlin? Pretty the same. We just define an interface bird and interface flyable with the same fields. Let's move to the next slide. The second thing author did is defining classes. But here is not classes, here is struct. Struct in Swift is pretty similar to class in Kotlin, but it's not reference type. And that's basically the main difference. Class is reference type and struct is not reference type. So let's think that it's classes, okay? And again, we have SwiftBird, which is bird and flyable, and SwiftBird can fly, and it has airspeed velocity, which depends on the value, and some initializing block, which takes this version. And we define in penguin. It's a bird, but it can fly. Okay, let's move to the next. And it's Kotlin code example. Okay, we have pretty the same. It's not structs, it's classes. We take inversion as a parameter to the constructor. We declare in values with the same way. And Kotlin also can fly. And it's Kotlin bird. Did you see the Kotlin bird? And if you didn't see, it's right here on the slide. You just have to look carefully. Okay, and also we have to declare penguin. It's also bird, has name, and it cannot fly. The next thing is how to simplify this code. Here I wanted to add extension. Protocol extension in Swift is used for providing default implementation. So it's pretty clear that every flyable bird can fly. So in Swift, we just declare in can fly variable where self is checked by flyable type. In Kotlin, we don't even need extension. We can define it right inside the interface. So let's see this code. And my question to you, will it code work? Will it compile? I'll give you a couple of seconds to think. Where is the trick here? Yeah, this code will not compile. And the main reason is that in Kotlin it's prohibited to add default implementation for values. We can add default implementation only for functions. So let's rewrite it. We're adding get, overriding default implementation of get function, and we're done. Okay, what's next? Next example, it's harder to understand, especially for Kotlin engineers, because it breaks the brain when you are looking on the code like this, but it's quite simple. Here we have custom string convertible, which is pretty the same as toString from the Kotlin, and any class which has custom string convertible, which implements custom string convertible, have to declare and override description. And here we declare an extension for custom string convertible where self is bird. Again, this where keyword. And if the bird can fly, it will print can fly. If not, can't fly. In Kotlin, it's even simpler. We declare an interface, custom string convertible. I declared it just because we don't have such interface. So just to give you an example, and I even added default implementation to custom string convertible. And also I declared interface bird and implemented custom string convertible and made a realization. And as you can see, we can call can fly directly inside because we're bird. Okay, but Kotlin also has where keyword, and we can even make this code look like Swift code, more like Swift code, let's say. Here, I declared custom string convertible interface just as marker interface and added extension property description, where T, our type, is custom string convertible and Word at the same time. More than that, I could even add default overriding for this description field for different classes like where t bird, where t, I don't know, eagle, and so on. And as t is bird, we can use can fly inside this function with generic. And generics are so powerful in Kotlin, I love them. And we even can rewrite all the bird class like this, making our properties like extension properties. But don't do like this because it's not Kotlin native way of working with interfaces. So let's move on. And the last thing was bringing it all together. And author called this article bringing it all together, so it's kind of the end. And he declared Racer protocol, and he added Racer's array. And also he declared two extensions for SwiftBird and for Penguin, where SwiftBird is Racer and Penguin is Racer, and declared speed, airspeed velocity for SwiftBird and 42 for some reason for Penguin. If you know why 42, you can you can write the comment. Okay, and now we are working with the array of racers, and it looks pretty the same, you know? Do you remember movable from the previous article? Racer is just the same like this movable. Uh, again, dependency inversion, interface segregation, and so on. I don't I don't even show you Kotlin code because you also should understand that it's implementable in Kotlin. And I think in any language which supports traits, which supports base principles of object-oriented programming and so on, I've read that even PHP language supports traits, so maybe PHP is also protocol-oriented language, but I didn't check. But how POP can help? Because yeah, we saw that POP is not some the new way of programming. Is just some set of rules. So let's review how it can help us. So the first thing is duplicated code. Here we have two view models with pretty the same code. View models using uh, repository, the same repository users, and declaring the same request with the same, not the same parameters, but they're using some parameters and then making some request to the repository to get this. I'm using viewModel inject is annotation from Hilt library. If you didn't have a chance to look at it, I recommend you. It's nice. Okay, and how can we solve this issue? I think the first solution is to move some logic to some abstract class and then extend from this. But we're already extending viewModel, so it's not the option for us. And even if we didn't have this viewModel, it's really bad practice to. It's wrong inheritance usage. So I wouldn't recommend doing this. The second thing is using some extension function, for example, or adding get users by params method right inside the repository. But in some cases, you couldn't have access to users repository, for example, if it's in some private SDK, for example, or for some other reasons. And also, if you're working on some big project, that's what happens. Developer thinks like, okay, it's just a one small function. This class is not so big. And then another developer thinks the same. And then we have really huge repository class with millions of methods. So don't do this. And the third solution I would review here is using traits. So let's see how we can refactor this code. We have has user info interface, which is trait, and get users by parameters inside it. And we applying this trait to the view model using and also we're adding override value because inside trait we have dependency on the user repository. And that's how we can solve duplicated code issue. Let's review the next example is composing and decomposing using traits. We have the same repository. It's quite big. It contains logic about users, logic about family tree, and we can also decompose it. Let's try. We're declaring interface trait for has user info, which works with users. We're declaring the same trait for has family API, which has dependency on API and encapsulates logic about family tree. And then we applying these traits to the repository, providing some dependencies using override keyword. So in conclusion, I want to say that it seems that POP is based on the well-known old concepts, on solid principles and traits, and it doesn't matter which language you are using. I like Kotlin, but I also like Swift. It's nice languages. So I didn't want to uh, make some holy war about which language is first protocol-oriented language in the world. I just wanted to show you the new concept and remind you about solid principles. So thank you. Alexander, get back.
Thank you, Artem. It was really interesting talk. I think
Thank
we
you.
can move to questions.
Yeah,
Uh,
sure.
I have a question. What language, Kotlin or Swift, do you actually like more? Without depending on the platform.
Of course, I like Swift. Oh, sorry, I like Kotlin more because I'm Android engineer. But I think that if I were iOS guy, I would definitely answer Swift because after years of Objective C, you shouldn't answer it other way.
Nice, thank you. And unfortunately, we have, as I see, only one question by audience, and uh, this question, I guess, already answered. But you can answer it again.
Okay.
Question by Rahman Kol. I think I know who it is. Uh, can you port Kotlin to Swift or vice versa
Whoa.
using script?
It's nice question. To be honest, I don't know. I think it's possible somehow, but why do we need it? We have Kotlin multi-platform, and we can write Kotlin code for both platforms. And if you already have Swift code, some Swift code, you uh, can stay with it and just add new logic using Kotlin multi-platform. It would be a nice solution. But maybe we have some script. Um, we can Google it.
Yes, we can. We always can Google. Thank you for your answer. And we have one more question by Andrei Gordienko.
Hmm.
Uh, is conforming to interface in Kotlin implemented via inheritance relationships? Oh, it's a question. Via inheritance relationships. And is conforming to interfaces is limited only to classes? How about other base types like in Swift?
Yeah, we can also use extension functions for work with all of the types. So you can make the same extension for example, string from standard library, or for integer, you can declare extension function. It's not a problem. It looks exactly like in Swift uh, with a bit different syntax. I hope that I answered your question. Thank you.
And we have another question by the same person. Uh, can you add or plug in new functionality to some Kotlin class just by making it conforming for some interface?
Yeah, as you saw in my presentation, we had such code example where we just added some trait to the Kotlin class, and um, Kotlin class had this logic inside. Or another solution is delegation by implementation. You can just declare some interface, then implement this interface, and using keyword by delegate implementation to some other class. So out of box, you'll have some logic from other class inside your class. It looks like multiple inheritance. Yep. Thank you for question. Sasha, are you here with us? Okay. Uh, it seems that Alexander is left. So um, the last thing, I want to thank you for all of your questions. We'll write the winner a little bit later in the comment below, and we come back to you to give your prize. And I'll see you a little bit later on the next talk. Don't miss it. It will be about security in Android. And I think it also will be useful not only for Android engineers, but also for iOS and cross-platform guys, because security is quite a common thing. Okay. Thank you once again, and see you a little bit later. Bye.